Today we're going to create a rope twist leg for a coffee table, and we're going to start with a 3.5 by 3.5 by 16 inch block. I want you guys to go to Gadgets, click on Wrapping, Wrap Job Setup, and then we're going to have a 9.5 inch cylinder length. Even though this is 16, we're only going to make a rope for 9.5 inches. Our cylinder diameter we want to end up with is 3.25. Make sure you get the decimal point in there. Make sure you're on inches. We're going to go along the X axis. No, we're in Y axis always on our ShopBot. The XY is drawing origin, top right. We're going to do center of the cylinder axis. This time you're going to click on simple cylindrical wrap. Click OK. We're going to go to Gadgets, under Wrapping, under Create Rounding Toolpath. The size of our square is 3.5 inch by 3.5 inch and 16 inches long. You want to make sure that this dot is highlighted. We're going to go down here to rastering. We're going to start with a square because we're going to leave some of these ends square already. So you want to make sure that the rastering down here is clicked. We'd like an allowance of 1/16 of an inch, and we've typed that in here. Of course, we gave it a toolpath name of Square Corner Hog Round. You can name it whatever you want. We're just trying to get rid of the extra material we do not need. Our cylinder length, 9.5 inches. Our cylinder diameter is 3.25. We're on the Y-axis. Click OK. We're going to go up to Toolpath now, so click on Toolpath. You can see that a toolpath is created, and we can look at the 3D view, and you can see that it does show your toolpath. The extra lines here are showing the corners that it has to go through to cut. If you want to see that that is round, we can go to Toolpaths, and under Toolpath Drawing you can click on Wrap X Values, and you can see that it's going to show you a cylinder. You can click on Preview, and we can preview Toolpath, and then it gives you a cylinder. Don't worry about that it's empty inside right now. We're just concerned with the outside. And so you have a cylinder. Most of the time we'll be looking at creating a new file in Aspire. This time we're going to go to Gadgets. We'll go to Wrapping. We're going to wrap our job setup. We're going to get the length of our piece. And what we're doing is we're going to make a leg for this coffee table, and we'll have a square block on the bottom here. This will be the bottom of the indexer. Top block of the indexer. In between here, this is what we're drawing. We're doing a rope twist. So you'll need to make sure that you have 15.5 inches, which is the total length of the leg, minus our 1/2 inch. This is very important to make sure that you do at the maximum 2.25 inches square. It'll fit in the Novichok, and add that onto any dimension of a leg. If you're making an 18, make it 18.5. In our case, we're making a 15.5 inch leg. We made our block 16. Notice that I made it 3.25 inch on the cylinder diameter. That is going to be the radius around the rope area. However, my block is 3.5 by 3.5. So the reasoning behind that is when the indexer will cut and make the rope, we want to make sure that it's going deep enough so we don't leave any flat spots on the top of the rope twist. This will happen on a generic lathe as well, so you always have to cut a little bit deeper. On the indexer, we just do that to make sure that we have some depth of cut. You want to always click on the Y-axis on our ShopBot indexer. This is explained in our previous video. Notice that we've selected under your XY drawing origin the top right hand, which is the bottom of our leg. Always click on cylinder axis, because that's taking us from the center point there, and that's where we Z and we center the Y, which is very important to get right in the center of that so that you can end up with your correct size. Look at spiral wrap, and we want to click on that. If you were just doing a simple cylinder, a round cylinder, you would click, of course, on the icon simple cylindrical wrap. If we're on spiral wrap, click on that. Number of revolutions, what I want to end up with is 6 pieces of rope on top of each other. This, however, you can select a different amount, it'll wrap differently. Notice how our screen looks, and this is going to be a little bigger and maybe might not look correct to you. We'll cover that, but as soon as we wrap this, it'll make total sense to you once it wraps the drawing all the way around. Now we're going to set up the ShopBot Indexer. We're always dealing with 3 axes. We want to center over the tailstock. What I did earlier is we used a V-carve bit, since it's so pointy, and we adjusted the head down so that we're centered right over our tailstock, because as soon as we give up our x-axis, this has become used by our indexer, which is b-axis. So you'll only be able to do z, which is up and down, and we'll z it here in a moment, and we'll be traveling on y-axis, and our indexer is the b-axis, but it gives up x. So if we set up offset of this, it's going to mess up all of our calculations we've already done on our former program. So when we're going to do a Z, you want to cut a block that's dead center on height, and we can put our Z plate down, and then you'll click on our Z and it'll come down and touch. So now with your ShopBot running, we do have our Z plate in place like we just showed you, and we're going to come up and double click on our Z plate command. It'll always throw a box up just as a secondary safety, and enter when you've got the plate right where you need it. Just click OK, and you'll notice that it's going to come down and touch twice. Do not forget to move this. We've had students leave it here before, and it will get thrown out of the way. It can tear bits up, can tear other things up too. So you can see the end. The reason why we put this data on is so it'll fit in our Nova chuck. And you want to be able to put that in, snug that up some. Before we do that though, we found center of the end of our board so that we can find center of our tailstock. And you can just adjust this in. Make sure you're snug up in the Nova chuck. Tighten this Nova chuck down. If you're not sure if it's tight or not, put it in a secondary hole too, and make sure you're tight. Tighten this up. Make sure you turn the ShopBot off so you're not fighting the servo motor to try to level this up. And now you can see how you can rotate the servo motor. If it's on, you'll be fighting the motor. We don't need you to tear up the motor. You can just get a common square. You can use the front of the motor and level it. Notice how I'm sitting nice and tight to the motor now. That's sitting nice and true. And there you go. Now we can turn it back on. You'll have to hit the reset. Click on OK to get that box out of the way. Now we can set up and Z our Y coordinate, which we've already done. We've went into our 0 command and 0 command, and we clicked on that, went to y-axis and zeroed it. Now we have Y, Z, and X, or which becomes B on the indexer, all zeroed, and we're ready to do our rough cut. We're doing our rounding path at this time, so we've already set all of our coordinates. Notice that we're leaving the top and bottom of the turning square. This is because this is the style that we want. We're just doing a round, 2 squares on top and bottom. If we were going to make a full radius all the way around, such as this one, we would 45 the corners off, so it would be less work for the CNC. You want to load your part file, go to Square Corner Hog, click on it, open the file, start, and set the router RPM to 12,000, excuse me. And ours is already set on 12,000. We're good to go. Click OK. At this time, this is where you can make a bad mistake. Make sure that you turn on the green start button before you say OK. If you accidentally click OK, it will drive this cutter into your work without it cutting. And you could break the bit, you could hurt the servo motor. So make sure, turn it on. Notice it's not moving anywhere until you click OK. Case while you're running your cut, always make sure that you have your hand on the mouse, because you could stop it at any time. If you see it's going to cause a problem, this is your backup right here. And if not, you can take the keyboard with you and shut it off. Always watch your work, especially if you're just unsure. I intended to show you this. We Z'd off of the center of the cutter. This is a 3/4 inch cutter. So where we wanted 9.5 inches, this gave us an extra 3/8 and an extra 3/8, which give us 10.25. So this is a very common mistake that we do not want you to do. So whenever you have a cutter, you need to find the outside edge if you're cutting between square and square. If we were just doing a full round, you wouldn't have to worry about that, because the cutter would be off the board a little bit, no problem. But when you're going between pieces, add from the center out, take that away. Your Z point should have been in 3/8 and 3/8, or you should have set up for 8 3/4 center to center. To better explain our XY origin, we've selected our top right hand on our XY coordinate. Let's look at the ShopBot table, and let me explain why that's easier. On our table, this is our home of 0, 0, X and Y. X is condensed to nothing, it becomes B, so we're only worried about Y. We select the top right, just so if you follow me over here, that Y starting point is closer to the indexer head, which holds the Nova chuck. If we have any problem from 0 on, if we're going to hit anything, it'll hit the tailstock, which is less costly. It won't hurt the servo motor either. If we select the bottom and try to start from here, there could be a problem with hitting our Nova chuck, which is expensive, and damaging our servo motor. So that explains why we start on the top right with our Y. After we have our dimensions on here, you can see that now we're at spiral wrap. We've selected 6 revolutions. This goes with our sketch of our leg that we want to have 6 ropes on top and bottom, square of course. We're going to click OK. We've got a layout here and it separates into 6 different areas or 7 spaces. You can also look, just to help you, we've got a strip of paper here, and I'm just going to take a pencil, which is a cylinder, and we're just going to wrap this around, and you'll start seeing how the spiral wrap of the Aspire program will make our spiral cut. Since these 2 rails are not perpendicular to a true 90, we're going to draw a box, and this box we will rotate so that we will sit at a 90 degrees to our 2 rails. This is important to be able to come up with a true 90 so that we can measure the width of our 2 rail sweep. So we'll go from 0 to the other, and you'll see that it's 1.5815 is our distance that we'll be working with. We'll click closed. We'll go ahead and we're going to draw another box that now we know the dimensions on X is 1.5815. Our height is half of our cylinder, which is 1.625. We'll move that box down and we're going to position it basically at our start. The reason why we want to start with a square is just like our rough cutout. Remember that this is in our Nova chuck here. We want to start from square because we're going to have a transition from square that's going to work into the rope. If you don't start with a square box, the rope will just die into the square and it doesn't look correct. You'll see this as we work on. Now we're going to use node editing, and we're going to delete the bottom of this box. We have to have it open. 2 rail sweeps only work with open vectors. So you can see we've added several geometric shapes. We've went from a square to a radius, and you can see the cross sections on our screen as well as on the turning here, that we're going to have a transition point from square into the rope. We've deviated a little bit just to show you a different geometric shape, such as in the center. We're going to put a V groove in the center of our rope just to show you the capabilities of the ShopBot Indexer, but also your own capability. You can put any geometric shape in any of these sections and come up with your own design. So we've deviated from the rope twist and just added another element just to show you some capabilities. We're going to create our 2 rail sweep that will create our 3D object that will wrap around our cylinder. You can see the different geometric shapes. Choosing them in order is very important. We did a double of our rounds so that we could make a tighter transition to the end. As you can see when we zoom into our layout, that all of our lines are crisscrossing on the top. So if we back out of this you can see if I click on node editing on our first line, it has a start point in black and it goes to a green, which is our finish of our line. When we click on our second rail, we start with black and we end in green. Well, you can see these are opposites, starting and stopping from each end, and once we collect that, it goes in a circular motion. Well, that gives you black to black, green to green, which gives us that crossover. So to fix this, we go to reverse rail 2, and you'll see that it will straighten out our profile of our particular rope bead. So we're going to go to scale to exact height, which is 1.625. We're going to apply that. We're going to close. We're going to go to our 3 view, and you can see by adding that center point that it has a very pointed center area, but you can see from square into the rope into our pointed center. Now let's go ahead and wrap this so we can see what our cut will look like on the leg itself. You can see that we have a good transition going from square into radius, and you can see our V point right in the center too.